I hope you are, after the great lunch, you are pretty relaxed to learn about some new stuff, because today we had a few talks about fantastic things like machine learning on the front end, and I'm pretty sure that it's not the only the surprising thing that you will learn today, because we can detect the face in the browser. So, as you may guess, my talk is about face detection in the browser. But before I move on, I want to introduce myself properly. So my name is Mirek. I'm front-end developer in Swing Dev company. After work, I like to travel, to go on a vacation, do some other boring stuff, right? It's not interesting for you. What's interesting is that I like to play with new browser APIs. And I think of myself as the web enthusiast. And I'm pretty sure that I'm not alone here in this room. And why is that? And because front-end is great, and this can be trivial, but the front-end gives us plenty of possibilities to add new value to our applications. So, for example, we can build a VR, AR games. We can use databases on the front-end using the IndexedDB. And also, we can mine cryptocurrencies. So, oh, sorry, some website tries to mine the crypto using my browser. But there is one also thing that we can do with our browsers. We can detect the face and recognize the face. And they, at the first sight, they seem to be pretty similar, but they are not. They are very different. So face detection is the first step in face recognition process. Oh, I see that this screen is familiar. So the face detection is this first step in face recognition. So we get our image. We find if in this image is any face, and our job is done. So simple. But on the contrary, the face recognition takes this one step further, and the face recognition allows our program, the computer, to match the certain face with the specific person. For us humans, it's very simple task, but for the computers, it means hours of learning, and it can be achieved, for example, using the machine learning mainly. But let's go back to the face detection. Maybe it's not that exciting as face recognition, but it still has a place in our industry. So the first example of usage of the face detection is the Snapchat filters. The Snapchat users may be familiar with the filters, the doggy face filter, the rainbow face filter, and so on. And recently, what's surprising, that Snapchat added support for detecting the cat's face. So you can put the filters, for example, the doggy face, I hope so, I didn't check, on your cat. And the next great example of the face detection is the feature that I think pushed all the customers to buy new iPhone X, right? So the Animoji. And the last one is the face detection in your camera. To be honest, I'm not much of a photographer, so I didn't know that I have the face detection in my camera, but I have. So it's amazing, right? And how this face detection works? The concept is very simple. We get the input, we normalize it, analyze it, and get the result. And that's the whole process. And I wish that it's that simple, because it's not. There are many academic articles that treat about this problem, and face detection is that complex that it needs to be approached from different angles, and many algorithms, many classifiers uses all these three methods, a combination of these 4 methods to detect the face, because building not solid face detection means causing the heart attack in our users. So we talked about accessibility. We need to also care about the health of our users. So let's go back to the face detection in JavaScript, because that's the JavaScript conference, and I decided to prepare to show you how to do it in this language. So I tested 4 popular approaches, methods of building the face detection in JavaScript. Only one of them requires the backend application. The 3 of them runs directly in our browsers, so you don't need to connect to your server, which is great. So the first approach, the first method is the OpenCV and Nodejs. So OpenCV is a very popular computer vision library. It's open sourced, maybe that's why it's popular, and also for us, for JavaScript developers, because OpenCV is written in C++, we can use it in Node.js. How to do it? We just grab one of the libraries that provide the bindings for the OpenCV for Node.js, and we can use it. So I use the OpenCV for Node.js. It uses the OpenCV in version 3. So to detect the face using this library, the OpenCV, you can use the Cascade classifier, which is the same as Viologens classifier from previous version. Also, this classifier uses something called har features, which I will talk briefly a bit later. And for example, to get the image and analyze it on the backend, you can stream the image via WebSocket. So for example, it's very useful for analyzing the stream from the webcam. So what are those har features? The har features are features or characteristics that defines the certain parts of the object or the face. So for example, we have it's normal that the area of the eye is darker than the area of the cheek, right? Because that's how it's shaded, right? So we can use this feature to detect the position of the eye on the face. Then we can use other features to analyze and define the other features of the faces. We combine them and we get the face. That's the basic concept. So here's the code, how you can use it. Here's the code from the backend side, and here we use the Cascade classifier. We get the encoded image, or it can be a video stream source in base 64. Then we decode it and get the results. Then with the results, we can send it back to the front end. And for example, we can draw a rectangle to show where the face is. The second approach, the second method is TrackingJS, and TrackingJS is the same classifier that the OpenCV does, and also it uses the har features. The TrackingJS runs entirely on the front end, so you don't need any server code. You just define the classifier, which you want to use, and then get the results. And next, you can grab these results and draw the rectangle. That's basically how my demo worked. So I mentioned about cuts. It's possible that to build a cuts face detection on the front end, and I'm pretty sure that the next library can make it happen. I saw that it was mentioned in one of the previous presentation about machine learning, because face APIJS is based on the machine learning and on the TensorFlow.js. So to detect the face, we use the pre-trained model. In my example, it was MTCNN. It's multitask cascaded convolutional neural network. Very long name, but the concept is very simple. It also, this model helps you to find the 5 point of the face, so you can find the position of the eyes, of the mouth, and of the nose. And then using these coordinates, for example, you can place some sticker and recreate the Snapchat filters. It also has other built-in models, and the 68-point face landmark detection can be useful for mobile devices because it's very light. So how this MTCNN works? So we get our test image, we create the pyramid of the image, so these are the scaled down images, we seed the network with them, then we get the proposal, then we get the refinement, that's the stage 2, and the final, we get the output. And here's the architecture, how the this network look like. So the first one is the proposal net, so it gets our initial proposals. The refinement clears all the wrong detections, and the output gives us the final result. And the combination of these networks gives us the better result than this single neural network. So how we use it on the front end? First of all, we need to load a model, and you need to be warned that this model is pretty heavy because it has 2 megabytes size. So load it once and use it everywhere. Then, when you have this model, you can grab the results using the async API, and then draw the rectangle to see where the face is. The last method, and in my opinion the most exciting one, is the native face detection. Did you know that the Chrome has built-in face detection? I didn't, but I found some article, and it really has. So the shape detection API that we can use in the Chrome, for example, is not a standard. It's provided by the Web Incubator community group. It's a group that proposed some new APIs to modern browsers. This shape detection can not only detect the face, but also text and barcodes. And under the hood, it uses the native implementation of detectors. So, for example, for the Apple machines, we have the VN detect face landmarks request. For the Android, it can be different. So I mentioned that this face detection, this shape detection API is not present in all browsers, only in minority, and unfortunately it's available only in Chrome and Firefox. And honestly, I tested only in Chrome, because still it's an experimental feature. So how to enable it in Chrome 69 Plus? We need to, as it is an experimental feature, we need to enable the flag of these experimental features, reload the browser, and we get access to face detector interface. Then we create a new face detector, input the source that we want to be analyzed, and get the results. It's also the async API. So to compare these 4 methods, I created a simple benchmark which consists 2 tests. The first one is the single image detection. So you upload the single image, and you can see how long it takes to detect the face, or even if this detector detects this face. And it measures, like I said, it measures the elapsed time of the detection. The second one is the frame rate of the detecting face in real time. So on the side note, this demo is available online, so you can go and also do these weird faces to test how it works. So this test tests only the frame rate, and you can also see how accurate is each of the detector. Of course, the benchmark needs some charts, so I prepared one. Or maybe two. So the first chart shows you how many detections are made by each of the detector, each of the method. So here the native API and OpenCV are the best. The face API, unfortunately, not. It also may vary depending on the settings that you provide to the face API. The second charts show you how long it takes to find the face for each of image. So as you may see, the slowest one is the face API. But in my opinion, it's not that bad, because you get the long response, but you have the higher accuracy comparing to the, for example, TrackingJS. Just try to tilt your head a bit or rotate it, and you will see what I mean. So this demo, this benchmark is available online, and it's on Heroku. So there's one thing that occurred during the testing on Heroku. The OpenCV requires not only a good machine on the front end, but also on the backend side. Because here I needed to limit the FPS to not to have the good performance. On the local machine, it runs great, but when you push it to the Heroku and you use the free dynos, it has some problems. So, like I mentioned, the face detection is very complex, but very interesting concept. So if you want to learn more, I suggest you to take a look at those links. I think this presentation will be available online. Yeah, that's the second part. And at the end, you need to remember that face detection and face recognition is very hard to work with. And even the best players like Apple had problems with it. So building robust and solid face detection needs some work, but it's worth to try. Thank you.
We do have, believe it or not, there's a couple of questions for you. So the first question that was actually on the list is, are there any products right now that are actually using this web-based API for detecting faces?
To be honest, I'm not aware of, but probably, maybe. Mm-hmm. I think this technology is pretty promising because, like I said, when you combine the OpenCV and Nodejs, you get this problem that you need to have both machines, and also the connection needs to be stable to detect the face. But when you do it on the front end, okay, it's not as performant, but still you are isolated from the back end, and you can do it entirely on the front end, and even it can work offline.
Okay, can you go back to the link, because I'm sure that people would like to check it out. Yeah, this is the link.
Yeah, below is the code.
Yes.
On the GitHub, because okay. I think
another question that is actually very interesting. It's not completely related to web development. It's about GDPR and or RODO, as is known in Poland. Like, the question is, are there any? I know you have to get permission, right, to use user's face in order to detect it. Are there any, mechanisms in the browser? Basically, do you get a pop-up asking, "Hey, we are about to detect your face. Is that okay with you?"
Surprisingly, not. So, with the only permission that the browser asks you for is the webcam access. If you want to detect the face from the webcam, and and that's why you should do face detection instead of face recognition. I think that face detection, because the face detection detect a general face, that doesn't have problem with GDPR.
Okay, but in any case, if you accept that, okay, this app can use webcam, it can also say whether a face is in the picture or not. Okay.
Yeah. Yeah.
Another question was, because like you mentioned that you experiment with various APIs, you know, face detection, also WebVR. What kind of sources do you use to find about new APIs?
To be honest, one of the great sources is the Google developer articles. I think also Twitter is very helpful, and Medium. I strongly suggest you to, and also take a look at your newsletters, because in your newsletters you have a lot of stuff, a lot of new stuff, and during the finding the materials for this presentation, I also encountered for this web incubator community group, which proposed a new APIs. The Google, for example, the Google developers are the part of this community group, so they try to add new APIs, not only face detection, but also the Bluetooth, the payments, and so on. All new cool stuff that we get.
Do you know if there are any plans to include this API in other browsers?
I think the Chrome 70 should have this, according to their plans, should have this face detection enabled by default.
What about IE8?
Sorry, we need to.
Okay.
We need to end this presentation.
Yes, no worries. There was one more question, which is more of a technical one. On this chart that you've showed, is when you were benchmarking with OpenCV, did you also count the time it takes to talk to backend?
Yes, this chart also includes the response time. I tested it locally, so yeah. So like I said,
so it was very fast.
Yeah, it was very, very fast. So I get the 120 FPS. So it was. I think it's not a right result, but it was very, very fast. But at the time when I pushed it to Heroku, it's slowed down very much. So.
Okay, so this is why you should go serverless, I guess.
Yeah, exactly.
Okay, thank you very much, Mirosław. It was fantastic.